Ever wonder how your bank, your social media feed, and your online shopping cart all just work? Well, today we're pulling back the curtain on the hidden world that makes it all possible. We're going to trace the incredible story of data, from total chaos to the super smart systems that basically run our lives now.
So let's start with a little thought experiment. Think about all the things you use every single day. Your banking app, that social feed you can't stop scrolling, your Amazon wish list. They all feel totally different, right? But they all share a secret ingredient under the hood.
Yep, the answer is databases. They are the invisible workhorse engines that store, organize, and serve up the insane amounts of information that make our modern world go round. But believe it or not, it wasn't always this neat and tidy.
To really appreciate the slick systems we have today, we've got to go back in time. Back to the early days of computing, which, honestly, was a period of digital chaos where just finding stuff was a huge pain.
Before we had proper databases, data was just kind of shoved into these simple, disconnected files called flat files. Think of a basic spreadsheet or a text document. And here's the crazy part. Every single application had its own unique, custom way of reading its own files. They were like these little digital islands that couldn't talk to each other at all.
As you can imagine, this old way was a complete maintenance nightmare. I mean, say you needed to change your address. You'd have to go hunt down and update like 10 different files in 10 different places. And if you missed just one, boom, instant inconsistency. And just trying to search for information, forget about it. It was slow and incredibly clunky. Clearly, we needed a better way.
And that better way arrived in 1970. A researcher at IBM, a guy named E. F. Codd, published a paper that just completely changed the game. It was the beginning of bringing order to all that chaos.
Codd's big idea was honestly revolutionary. He basically said, hey, let's stop worrying about how data is physically stored on a disk, which file it's in, what the format is, and let's just focus on the logical relationships between the pieces of data. His solution? Organize everything into simple tables.
So just look at this mess from the before times. If a customer, let's call him John Smith, buys 3 different items, his name and address get typed out 3 separate times. That's super redundant, and it's just asking for errors. What happens if someone misspells his name on that 3rd order? Now your data is a mess.
Codd's relational model fixed all this by just splitting the data up. First, you create a nice, clean, simple table just for customers. Every customer gets a unique ID, and their info is stored in one place, and only one place.
Then you make a totally separate table just for the orders. And here's the brilliant part. Instead of retyping all of John's info, you just use his unique customer ID. That ID acts as a link between the 2 tables. So now if John Smith moves, you update his address in exactly one spot. It's so elegant, right?
And this model, along with the language they built to talk to it, SQL, became the undisputed king of the data world. It was so powerful because it gave everyone a single, reliable way to work with their data. It spawned industry giants like Oracle, Postgres, and MySQL. And for more than 30 years, this was just how you manage data, period.
But then, something happened. Something that nobody back in 1970 could have possibly predicted. The internet showed up, and it completely exploded, pushing this beautiful structured system to its absolute breaking point. All of a sudden, applications weren't dealing with a few thousand users. They were dealing with hundreds of millions, sometimes billions of them. The sheer volume and speed of the data being created was unlike anything anyone had ever seen before. And the web brought a whole new list of demands. Your data had to be instantly available anywhere on the planet. And it wasn't just neat tables anymore. It was all this messy, unstructured stuff, like social media posts, photos, videos, you name it. And maybe the biggest rule of all, these systems could never, ever go down.
So that rigid one-size-fits-all model, it just couldn't keep up. It wasn't built for this new world. So the industry responded with this massive burst of creativity, leading to a whole new universe of specialized databases.
This became known as the NoSQL movement. Now, the name's a little misleading. It wasn't really about getting rid of SQL. It was about moving away from the idea that there's only one right way to store data. The new philosophy was all about using the right tool for the job.
And this led to a whole new family of databases. You've got document databases like MongoDB, which are kind of like a super flexible digital file cabinet, perfect for things like product catalogs. Then there are key value stores like Redis, which are like a giant dictionary built for pure speed, perfect for caching.
You even have graph databases, like Neo4j, which are designed from the ground up to map complex relationships. They're the secret sauce behind social networks and recommendation engines.
But this amazing new world of choice came with a catch, a big one, a fundamental, totally unavoidable trade-off that every single modern system has to make.
It all comes down to a principle from computer science called the CAP theorem. It says that when you spread your data across a bunch of machines, you can get three things: consistency, availability, and partition tolerance. Here's the catch: you can only pick two. And because network failures, those are the partitions, are just an unavoidable fact of life, you have to be able to tolerate them.
This forces engineers into a really tough choice. Do you want consistency or availability? A banking system will always choose consistency. It would rather go offline for a second than ever risk showing you the wrong account balance. But a social media feed? It's going to choose availability. It'll stay online, even if that means you might briefly see a slightly out-of-date post. There's no single right answer. It's all about picking the right trade-off for the job.
So that brings us to today. We've gone from this one-size-fits-all approach to having a special database for pretty much every purpose you can imagine. So what's the next chapter in the story of data? Where do we go from here?
Well, it seems the next great frontier isn't about building more types of databases, it's about building smarter ones. The big goal now is to create systems that can manage, optimize, and even heal themselves.
Just think about what that really means. We're talking about a database that can sense its own workload and automatically tune itself for better performance. One that can detect when a part is about to fail and recover before a human even gets an alert. A system that can automatically patch itself against security threats. And this isn't sci-fi. This is what the major cloud providers are building as we speak.
And really, that's the ultimate goal of automation. By letting the machines handle all the complex, tedious work of managing the data, we free up human brainpower to focus on bigger, more interesting problems. Which leaves us with a pretty fascinating final question. As our tools get smarter and smarter, what new challenges will we choose to solve?